Hello, y'all. Hope y'all doing well. Everything seems to be going fine. I think I changed up my setting a bit for the debate yesterday, so glad everything is still seems to be working okay. Let me know if there's any issues with volume. It seems like it's working okay. Welcome, Real Kindness. Good to see you. Yeah, man. Hey, oh, the matters now is it recorded? Maybe I need to check that out. Uh, uh, that's one of the reasons why I wanted to debate him. I saw him in one of his after shows, and he was saying like he can put me in his place, put me in my place, and stuff like that. And do you remember when I was having that debate with uh you know Toby and Allen? He kept sending me super chats, so I couldn't wait to get my hands on him. And of course, he uh you know doesn't know what he's talking about. So so yeah, so it was fun. I will be watching the video of MC Toon later. He'll be doing a sort of review and discussion about it, about the debate, and about uh, Whitsitt and his changing views. And also, I'm going to be on his show tomorrow. Let me change this backing a bit. On tomorrow, I'll be on his show and we'll talk about the debate. We'll do a review. So be sure to check that out tonight so this is going to end no later than 8:50, so I can go join his show and be in the chats. And then tomorrow at 9 p.m. Central Time. So just like how tonight MC Tunes will start at 9 p.m. Central Time, and then tomorrow at 9 p.m. Central Time, I'll be on MC Tune channels again. So you all probably remember being on his channel to do a dark energy talk. So that was fun. So I'll be doing something like that again. And did I overwrite it? I don't know if I overwrote it. No, I didn't. So there's a link. I understand people might be busy. You might not be able to join Real Cognition or anybody else, but if anybody wants to, you could join the chat there, and I'll go ahead and get started. So what I'll basically do is go through some of the math I did in my presentation, and it'll be pretty straightforward. And I think it will end by about 8:50, like I said. So what I'll do is solar rotation calculation, and I'll do measuring the Earth and the Sun. I guess I should say weighing, right? We'll weigh Earth and Sun. So these are the things that we'll do today. So after you finish today, you'll be able to see how this works, at least how I did it. I'm sure there's more than one way to do these things, but you'll see how I did it, and you saw the results I got in the stream. So the values are the same. I went over the values again before this stream, and it all the coding added up to the same, and so on and so forth. So you can check it out. So why don't you let me know, Real Kindness, what do you want to start with? Do you want to start with solar rotation? Do you want to start with weighing the sun and weighing the moon? Or anybody else who's watching, what would y'all like to start with? Just in case we start running out of time and I have to be short on one of them. Who would you like to see first? And Real Kindness is talking about Witz's after show. I'll make sure to check it out. He was on for a pretty long time too. It began as a dumpster fire, but turned into an ordinary school in Globers, and even taught everyone about the jobs too. I'll check it out. I'm sure it'll be fun. So Real Kindness said, let's learn about weighing the moon. So here's my share. Let's see if that's working properly. Everything seems to be good. So awesome. So weighing the moon. And it's the same thing as weighing the one as well, weighing the sun as well. Now what I'm going to be doing is looking at my trusty lab notebook, the class I did in this summer, which was a very good lab, is a very good professor, and I had to do this lab is the most serious labs I had to do. And even though I have a pad, the professor was like, "No, you have to have a paper notebook." So that's what I used that whole semester. So I got into the habit. So now I still use it a lot of times. All right. So I was talking about gravity. I was proving the shape of the Earth because of gravity. So that's what we can use to weigh the sun and the moon. And what I'll do, um, I'll put my chat and stuff by my camera so I could look at the camera more often. I'll put the Discord in the other window, and there we go. So it's simple as this. So we know that as I showed in the debate, that the everything has a mass. We're starting with the Earth first. So I'll put the Earth in the center, and I'll put the moon out here. And we know that the moon goes around the Earth. So this is the Earth, and this is the moon. And the way it works is we know that there's a radius to the moon, and the radius we get from radar ranging pretty easily. Not even radar; they have the detector that they left on the moon, so we could just send lasers to that thing and get the distance. So we have the distance pretty accurately, and we know that the moon is rotating. So I'm going to be looking at it from the top down view. So from the top down view, the velocity of the moon you can say is like this, but you can say the speed is pretty much going around the circle. But we can try to treat them as the same and simply say similar to how I put in the chat. If you have changing velocity, that's the same thing as acceleration. So basically, the velocity is going there, and at this point, the velocity is there. At this point, it's there because the Earth is constantly pulling on the moon. So we end up having a change in velocity over time, which equals acceleration. And acceleration around a circle is v squared over r. So basically, the velocity here with no uh, uh, arrow on top, v squared over r, that's the acceleration. So that's just like a given. And we also have F equals ma. So F equals ma. And I can go ahead and plug my a in. So F equals m v squared over r. Right? And all I'm doing is just plugging that in. We also know from the law of gravitation that F equals big G m. And here we're going to talk about the m of the Earth because we're trying to weigh the Earth. And m small is going to be the m of the moon, which is the m over here. So I wrote them both lowercase. And I'll sort of write it the same kind of squiggly lowercase. And we know that's going to be over r squared. So both of these forces have to equal. So I can go ahead and say that, I forgot to put my equal sign. I can go ahead and say that m over v squared over r equals big G m of the Earth m over r squared. All right, that's looking good so far. So all I have to do now is cancel out some things. So this is the same r because it's the r that's right here. And what else cancels out? This cancels out. So now we have v squared equals big G, the mass of the Earth, over r squared. So if I want to know the mass of the Earth, I can simply solve for the mass of the Earth and say me equals v squared. And then I not cancel out. Oh yeah, I made a mistake and wrote this r again. I canceled it out here, but I often do that like on my homework and stuff too, but you always catch it. But I canceled out that one r right there, so that's actually one r, not two, because it looks strange when I was bringing that r over. V squared r over v. All right. So what this means is that simply solving for this equation will give us the mass of the Earth. Not moon, Earth. The Earth is a different the moon is a different process. This is the Earth. So now we have to do, so the velocity, I'll write that in a different color. I'll try red. So velocity will be uh, uh, the Earth, the circumference. So we're going to basically model it as a circle because we know that these orbits are ellipses. But we'll say the velocity is distance over time. We know that. And the distance is going to be the circumference of the Earth, of the moon's orbit over the time of the moon's orbit. So that's going to be 2 pi times r over, and the moon orbits every 27.3 days. And if I work that out, I'll put in 2 pi aura. The radius to the moon is 384,000 kilometers. So when I plug that into the values, I get my V equals just about 1.02 kilometers per second. I forgot to write my per second on my paper. So I have to, because I'm going to show that to my mentor. I'm actually going to meet with my mentor tomorrow, my primary mentor, my research, and I'm going to present him my current data, which y'all saw first, ironically. And but I'm going to present him my code and everything else, and what I'm showing y'all right now. Not well, I'm going to show him this too, but this is technically not part of my research, but is in my research notebook. But I'm going to show him the second thing I'm going to show y'all with the how I measure the speed of the sun rotation. So I plug that in. I got my velocity, and now I can put that into the moon equation. So I'll just continue it from there. So that'll be 1.02 kilometers per second. And this is the same radius, kilometers. And that's going to be over. And G is going to be just about 6.674 times 10 to the negative 11. And that's newtons meters squared over kilograms squared. And when you work that out, you get 6 times 10 to the 24. And maybe I'll write it, always do the shortcut in my notes. 10 times 10 to the 24 kilograms for the equals the mass of Earth. So that's how we get the mass of Earth. So I misspoke if I said the moon is the Earth. So the way it works is whenever two things are in orbit, we can utilize we can basically model the orbit as a fall. So then we could use gravity. We could use the change in velocity as it goes around as the acceleration. And now we could incorporate F equals ma. So now I have the force of gravity, we have the force of acceleration. We could just solve for the big mass because there's an m on either side, similar to what I did yesterday. So it's pretty neat. And yes, Tune will be on tonight. He'll be on at 9 p.m. my time, which is 45 minutes from now. So I will be there. So hopefully I'll see you there as well, Real Kindness. He'll be doing a look at the debate I had with Witsit from a perspective of apparently Witsit was pulling apparently that ephemeris reference. I didn't know what that was, except I knew that when I read it, it said positions from the perspective of the earth. So it's like just pointing out where things are from the perspective of the earth is not a model, which is what I asked. If you go back to my original question, I said, where is Mercury going to, when is Mercury going to next be in their conjunction, and show us that with your model, right? Um, but I believe Witch is going to talk about where that really comes from. Apparently, is actually a heliocentric thing, but they just like make the reference frame based on Earth, but is really still based on the globe. But I'm not sure. That's what I think he's going to do. But I know he's going to look into that debate. And then tomorrow we're going to do, let me adjust this video a bit. And tomorrow we're going to do an actual review of the debate, me and him and I. So it should be fun. So I'll be there after this ends. So that's why I'm going to make sure I end at 8:15. But this stuff is not hard. Well, I mean, it's hard for flat earthers, but it's not hard for you, Real Cognites. I mean, it's pretty simple stuff. Now, the thing is, the same exact thing here. Oh, and let me check the Discord. Anybody join? Not yet. I'll see if anybody does Zoom meeting. So the way this works is this same procedure works for the sun. Okay. So what I'm going to do is, since I have this pretty drawing that I drew, I'll just copy it. Boom. And I'll change my colors around and all that stuff. Because if you look at even my actual homework and stuff, I always like have things color coded. Um, so in this case, this will be the moon, oh, excuse me, the sun. So we're measuring the sun now. And this will now be the earth. And everything works exactly the same. The difference is that aura will be, what do I have that written at? No, it's 93 million miles, yes, but it's 1.5 times 10 to the 11 meters. That's aura here. The velocity is still going to be the distance over time. So the distance is still 2 pi aura, which is that radius over 365 days. It takes the Earth 365 days to go around the sun. So that'll still be our V. And what other differences do we have? The V is a bit different. It's going to be 2 pi aura over a year. Uh, what else? Velocity, that's going to give us velocity. Radius, and that's it. So once you get radius, once you get velocity, you go back to the same equation. And this time, you're going to plug in. So this symbol here, which I know before I got into astronomy, I didn't really know, but this is the sun symbol. So wherever you see this symbol, it's talking about the sun. So the mass of the sun will be the velocity squared of the Earth, the radius of the Earth in g, and the mass of the Earth is the velocity of the moon, the radius of the moon in g. So simple as that, we can measure the mass of the Earth and the sun. Now, of course, flat earthers will say something like, it's just numbers, it's just math. They also say this inane thing, if the name is the word, it just sounds like a good word to use. So, but they'll say, oh, you could just model things anyway and just make it work by math. But no. Uh, uh, these masses are what, just like how when I talked about gravity in the debate, the distances that you get if you find distances to output the g, like if you start with the kinematic equation and drop something, and you drop it from this high and you time it, and you output g, it's only because it's being influenced by gravity. So by the same token, all of these masses, the masses and the distances, they matter. So you can't just willy-nilly throw stuff out there. So when you take these masses and everything, this is how we can, for instance, like you can kind of get away with it with the solar system with Kepler's laws because Kepler's laws are built upon a ratio, and you could scale the ratio up and down however you want because it's a ratio. But again, when we're talking about exact masses, like in my presentation, I talked about the Sirius stars. In order to apply the formula to things like that, you actually need the Newtonian upgraded version of Kepler's laws, which divides by the mass of the total system. So the mass of the total system will play a part, and if you don't have those masses accurately, then you'll have a problem using Kepler's laws, where we can look at the rotation to get the masses of those as well. So that's that. So awesome. So that's how I weighed. So these are how I got the values for the Earth and the Sun in my presentation. So we got a whole lot of time left. We're probably in early, have enough time to get a drink or whatever before we start looking at MC Tunes show. So now we're going to do solar rotation. This is going to be a bit more complicated. And this is my methodology. Of course, since I've started reading on it, because I have to write a theoretical part to the paper I have to write. And of course, I didn't invent measuring the rotation the way I did it, but I did want to do it my authentic, original way. So the way I thought about it is like this. So we have the sun here, and we have spots on the sun. And if we watch a spot on the left side, and then we watch a spot on the right, that same spot, is going to travel over there day after day. And eventually that spot will be on the right side. If I take picture one here, that'll be at the start of it being on the face of the sun. And pick two here will be, when it's on the other side. And Real Cognitive says you're literally making his point for him. Kinematic dynamic equivalence, bro. He ran from he ran from that integral like an Olympian. And look, if it weren't for the fact that he wasn't bragging over, and well, maybe I would have did it anyway, actually, because I did challenge Alan and Toby. Yeah, so I probably would have did it anyway, because I know, I know it deals with math a lot. So I guess I can't say that. I could just say that it made it even worse, the fact that he brags over and over and over, because I got that clip. Matter of fact, I forgot. I'm glad you reminded me of that. I meant to actually get all the links, but I mean I mentioned all the the places that they were in the debate. So if you just go to those streams, you can find it. But let me put the link to the Veritas one right now before not the Veritas one, but the Discord one before I forget. He lied, by the way, or maybe he just didn't know. I mean, it could have been just ignorance, but he said I had got some quotes from private conversations, but I didn't. Every single thing I got was uh was stuff that streamed live, that streamed to the world that everybody can go pull up right now. So, for instance, let me get this link right now, as a matter of fact, before I forget. So just go watch my debate with it, and you'll see where I call out all of the places where most of those things are. And let me see. Forgot what I named the bookmark. Okay, here we go. Don't mind the audio of this starts playing. Yeah, this is the one. So all you have to do is go in this link right here and go to in the video. Hold up, let me find the right place to drop this link. So go to this link right there. And what you want to do is go to the timestamp is going to be, um, hold up, my computer is going a bit slow since I have so much stuff going. 7:53 UTC. So I have 7:53 UTC in the video. Around that time, it's towards the end. Oh, well, that's my other channel. Towards the end of the video, and you'll see uh, 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 Whitsitt making the claims about a sphere can't cast a circular shadow on another sphere and other things. I didn't get a chance to play everything he said, but you'll be able to see that he said what I said. If somebody else thinks I didn't quote him properly, let me know. My idea is that I did. Y'all look at it and y'all let me know, because of course I don't believe what Whitsitt says. I mean, right in the debate he was lying. I mean, you saw him change his questions. Like he asked me one question, and then he interrupted me, and then he changed it. I said, "You just changed your question." And I watched the debate again. I went back and heard the original question. It's clearly different. And he said, "No, it's the same question." So I'm not gonna, and so on other things. So I'm not gonna believe him what he says. But I heard it myself. He said I played the clip. Y'all heard it. But if anybody wants to go hear the whole thing, go ahead and let me know. But you can hit it, watch the video for the rest. So this is my idea. So the way I look at it is the current thing to us is that Kindness said, of course, that maybe he shouldn't talk to his friends all over the internet. Exactly. Maybe to him he was having a private conversation, but everybody knows that Discord it's 24-hour streamed. There's no moment where it's not being streamed. It's always being streamed. The only time you can't find the recording is if sometimes it has an error in the recording. But other than that, every single second of it is recorded and streamed. So everybody who goes in there knows it says stream. This thing is streamed to streaming live. So the way I see it, everything in there is for a game. Just like how he finds anything he can on Einstein and anything else, and uses it against them. Good. So let's see. We have these 2 points. Now, of course, I went through every pick and it eventually found where it went. But on Earth, it seems like the angle is 180 degrees. That's what we might think. But we have to keep in mind that the planet is still revolving around the sun. So that into account, it would look something like this. So this will still be the sun here, and instead of it being 180, so let's say so this will be basically the left side to us now, and it's drawing a bit askew, but you see what I'm saying? So this full angle now will be 180 degrees plus the amount that the Earth moved. So maybe this line is confusing it a bit, but the Earth was right here. Let's call this the Earth. The Earth was right there, looking at both sides. And so the Earth was here, but now the Earth is here. So this angle I call theta, we'll say theta, what did I call it? So I can call it the same thing, theta ER. And this full theta is theta spot. So this will be 180 degrees plus theta ER, and that's going to equal theta spot. So that's how I got the angle that the spot moved to calculate velocity. Right, and I didn't catch that one, real kindness. Big cherry, hold up. Oh, big balls. Hold up. Mining. Oh, big cherry picking. That is awesome. Yeah, yeah. He's fine when it's him getting the quotes. If he's getting the quotes, yeah, okay, yeah, and that's recorded, so yeah, it was probably, but I wouldn't be surprised if that's true. But yeah, yeah, he's fine. Everybody knows, man. If you watch Woodsit, he's a quote mind bonanza. I mean, he is even as in his presentation, right? We didn't even start the discussion yet, and he was already doing quotes saying, even if it wasn't a verbatim quote, he was saying, well, Newton said this and Einstein said that, and this person's told that person that. And then during the debate, he was bringing up quotes, but he has a problem when it's quotes for him. And I think it's because he knows he can't run from what he said if I have the quote. And that's why I had that shucking and jiving thing, because we can see when he changes his words and everything, according to him, he's a liar. So now either you're a liar because you're shucking and jiving according to what you said, because you're changing what you said, or you lied when you said people shuck and jive when they lie. So which liar do you want to be? One way or another, he's a liar, according to his own words. It depends on whether he wants to be a liar the first time or the second time, right? But one of the ways he's a liar, right? So that's the whole thing of the spot. So basically what I did was I got theta ER is going to be the amount of days that it takes for the Earth to go over that distance, divided by 365 degrees, days times 360 degrees, and that's going to give us the fraction of the full circle or the full orbit that's in degrees. So that's how I got theta ER. And then I took theta spot equals theta ER plus 180, and that's how I got that in degrees. So that's easy enough. So that's the first two things I had there, theta ER and theta spot. Good. Maybe I should, no, I'll be good. I was about to say maybe I should underline these things. And Real says he's been doing this so damn long, he might actually even believe it. Man, let me read that again. That was a good one, and I didn't even finish reading it because I had like an aha moment. Real says he's been doing it so damn long, he might actually even believe his own BS by now. That is very possible. You know what comes to mind? Um, what is that guy's name? L. Ron Hubbard, who led when he was alive Scientology. People have come out now who were in Scientology, and they put forth that he plagiarized. They put forth that he, uh, uh, well, I mean, nobody his so-called technology worked for. It just didn't work, so it was fraudulent. Um, but at the end, when he was dying, he was like it'd be too long to explain the details of it, but suffice it to say, he was insanely rambling his doctrine and trying to make it work some kind of way, even to the point of almost about to kill himself trying to apply it to himself. So you're right, man. It could be such that he really believes it now. But I mean, it's hard to say. Like, I mean, there's times when I hear him talk, it sounds like he really believes it, but at the same time, he has to know he's lying. I mean, I don't see how he can not know, like the stuff that MC Toon has on his channel, like with the references that he put out. Like MC Toon has like documented pages that says Witsit's lies, you know? So how can you not know that the reference you got wasn't a valid reference? Or if you got it from somebody else, how can you say that you got it or it's your references that you got when you know you got it from somebody else? I mean, you have to know that what you're saying is not true, but when I played that clip about him what he said about the circle. I mean, in fact, I have it right here. I mean, I could play it again right now. Where's the one at? Hold up here. Oh, there we go.
Well, I mean,
Oh, I don't have it set up right now to play properly. I don't know what's going on with my
radius of light in all
whatever it
directions,
is.
so it's going to give you a sphere of light, right? But it's not like a solid sphere. You see what I'm saying? Like if something's illuminating, it's gonna be a sphere in that it's gonna have a radius of light. Same goes for the stars, right? Like if the stars
Is
were
that the
like,
one?
if I was up there shining really bright as a star.
Well, that's another one I didn't get to. That's why in the if you remember in the debate I had in red, Wizard is wrong about stars not being spherical object, and he's wrong to say that a human being would look like a star. That's why I put that one there. That quote is from that link I put into the chat. So if you go to the link in the chat, the Rumble link, that's where that quote is. But the one with the geometry, here's the one.
But what I really want to make sure, this is the proper way to do this. There's a claim on the table that we know what the eclipse is. It's that the spherical moon is getting in front of the spherical sun. That cannot be what's happening because the shadow is a circle. And spheres don't cast circle shadows on other spheres. It creates an S wave shadow. So we can throw that explanation out. It's been refuted with geometry.
So it's clear in that quote he said a spherical object can't cast a circular shadow on a spherical object. Period. That's what he said. So according to him, he's changing according to in the debate, and he's shucking and jiving. So he has to know he's. I don't know, but like you said, you have the cognitive dissonance. They must suffer. It's hard to imagine. Yep, he's been shown the lies many times. Yeah, like when you tell them when you explain something, and they ask the same question again, right? Like literally, like even the same day, they ask the same exact question. You're like, didn't we just cover that? That's why in the Discord that I used to be on, matter of fact, that Discord I linked when they started being rude to me, I stopped going back. But uh, one of the things I started asking them is, let me adjust this really fast. Oh well, it'll just be there for now. When I changed my settings for the debate, I used a different camera on another part, and it didn't work out too well. But what I started to ask them was, do you know that there's textbooks? And they'd be asking like, why does this happen like that? Why does that happen like that? I'm like, what have you done to try to learn it? Do you know that there's textbooks that explains anything you can ask about sun, the stars, the moon, gravity, anything? If we know about it, is in a textbook somewhere. Unless it's like absolutely new, unless it's like cutting edge stuff that somebody just discovered, like, within the last few years. If it's something that's established, it's in a textbook. It's in a textbook. So if they really want, like one of them was somebody, like one of the guys kept asking, how does something keep exploding again? Something explodes again. He was clearly talking about a nova, where that you can have like for instance a white dwarf that has a companion star, and it absorbs enough matter. And maybe it's not a white dwarf, but it's some kind of small object that absorbs mass from another object, and it absorbs the material on the surface that eventually ignites, and that a surface explodes. But then it draws some more material. It just keeps drawing material and then exploding and keep drawing material. Similar to how we can have like a charcoal grill, right? And we light it on fire and pour some charcoal fluid in it, and it lights up. But then when it goes down, we pour some more charcoal on a lighter fluid and it lights up again. Their stupid question is, how does that keep lighting up again? How can something keep burning over and over again? Because I'm pouring lighter fluid in it. Just like how the thing in space is constantly drawing more fluid from the neighboring, body. And then when it ignites, it has to build up again to ignite again. Simple explanation. But they keep asking the question, like you said, real, because they just denying it's the cognitive dissonance of the fact that answers are there. And apparently they believe if they ask the question, it means that that is wrong. They've deluded themselves into believing that if I ask this question about something I'm ignorant about, that means whatever it is wrong and can't be solved. But I started asking them, do you know that? Why don't you go? Do you know there's a book that has that in there? Explain. Why don't you go get a book? And the responses, man. Some of them would not want to address that at all. One of them was like, "Forget the book. I don't need to. I don't want to see the book." One of them eventually was like, "Okay, I'll get the book." But then one of the people said, "I don't want to hear the title. Don't ask them for the title of the book." And the guy who initially weakly said he wanted to get the title just didn't say that. I was like, "Look, they really want to know. They want the answer to be not there, so they can pretend that there's no answer, so they can pretend something is wrong with the model or the understanding or whatever." So they seem to want to be ignorant. So, and Real says, for instance, perhaps it can be circular as per pure geometry, but whoever even claimed perfect circle? Offhand, I maybe say it just looks damn circular because the moon is only like 5 DEG offset anyway. I mean, look, the image that I had up, I mean, it's circular enough. Where's that picture at? I'll add that picture real fast that I had of the one that's circular. So should be easy enough to just add that up into the stream real fast. Uh, so image, uh, it will be here. And thought I had it there. I didn't have it there. All right. Well, I guess I just didn't save it from the presentation. Let me save it real fast. Save. And it'll save here. Save. Oh, that's bugging right now. So I'll go back to here. See if I can find the image there. Yep, there we go. Done. All right, so you look at this, that's as circular as the baseball is. I mean, you can see there's a little edge to the baseball that makes it flat there. So, I mean, that's as circular as the object that's projecting a circle. So yes, the moon does have it's not like a perfect circle, but I mean, as circles go, at the resolution, we can see a shadow. Like the picture I showed of the ISS picture of the shadow, it looks like a circle enough. He was literally, if you in that quote you heard it, he was literally saying it can't make a circle. So according to what he said, he was saying this is impossible. Which is why I took this picture and I took the one with the baseballs to the side because the fact is, the if the solar eclipse is at the edge of the Earth, then it is skewed, and if it goes across the center, like if you look up this solar eclipse on April the 8th is in April, so it's in spring. The planet is tilting more towards the sun, and it happened in the middle of the day. So it stands to reason it'll be more towards the center of the Earth because that's just where the Earth is oriented. And since it's more towards the center of the Earth, the shadow will be more circular. So it all adds up with the geometry. Just according to what he said, is just not correct according to the geometry. So but it's nothing new for flat earthers. So let me undo these. Boom. So I'll wrap this up and then we'll end. I have 10 more minutes. So theta spot, got theta spot. Now, what I did next was the rotation rate of the sun. And all I did was take theta spot in degrees and divide that by the number of days. And that gave me the degrees that it rotates a day. Then to get the days per rotation, I got, now this one was a bit, I had to think about this one. So I basically did 360 degrees divided by RRS. Now the reason why I did that is this is going to end up being 360 degrees per rotation times uh, uh, um, RRS flipped upside down, which is days per degree from the first one. Degrees cancel, so that gives me days per rotation. Right, so that's how I got days per rotation. And so that's pretty much the hardest one that I had to think about. I mean, it's not hard now, but at the time I had to, when I was putting it together, I was like, I ended up having, I don't know, you see my notes, it's a bit messy. Like I had to work on that one a little bit, I remember. So then I got the velocity at the center. And all I did was for this one, oh, maybe this one was the most complicated one. Each one seems more complicated than the last, I guess. So I took DPR and I multiplied that by one rotation is the circumference of the sun around the center, right? And then I multiplied that by the number of seconds and the number of days. So we know that this is days per rotation, obviously, because it's called days per rotation. And we have 1 over the circumference of the Earth, and that's going to be in kilometers, right? And then we have this one, still seconds over days. So these cancel, the days cancel, the rotation. So this is, I forgot to rewrite my rotation. This is one rotation, right? So that's going to cancel. And this is going to leave us with seconds per kilometer. So that's why we have to do the inversion here. And this gives us kilometers per second. So this gives us how far transversely the ground, you can say, of the sun moves to the right. And then to get the velocity at the latitude of the spot, I simply multiply the velocity at the center times cosine of the angle, because if the angle is 0, like if on the sun the spot is at the equator, the angle is 0, so we get the full velocity. If the latitude is here, then this theta will go up, which means this velocity will be the latitude is less than the central. And that's how I got the velocity at the latitude, because the closer you get to the poles, the slower. At the center, it has to go very far to go to the same distance, but at the end, the whole thing is a shorter amount of distance and the same amount of time rotation, which is why it's wrong for the flat earthers to say rotation, like the Earth revolves at 1,000 miles per hour, because that only worked at the center. You can say transverse velocity at the center, but the rotation, is not quite the same. That's why I say velocity at the center and velocity at the latitude, and that makes sense. That's how I got that. So with 5 minutes to spare, I went through how I got the velocities and all that I put into the video, the debate, and and it's going to be in my research. Maybe I'll have to make another video to do the spectra, but I'm actually still working on the spectra right now. So I have enough to put in introductory, but technically I should probably find out how much element it is in each thing, but I really don't know how to do that yet. I haven't been able to figure that out yet. So that's why I just went and just got, can I find the elements? And I can find the elements. So now that I found the elements, I'm gonna have to work out how to actually find out how much elements are there about the width of the absorption line. So it's gonna take some time. And Real says, for an instant, perhaps it can be circular. I think we got that one. And it says, and of all things, that's one of his many globe killers. Oh, you talking about the circular comment? Like which one is a globe killer? The short, because I know I heard flat earthers. Matter of fact, that was in my first debate on MDD. Wotan said that the shadow can't be smaller than an object. When I showed him wrong, he's one of the liars. He's a truck-in driver using Witch's words because he changed his answer in the same debate. It recorded is on MDD. So, but his was new, saying that a circular object can't cast a circular shadow. But of course, he also said that a human being. Let me actually play that one. Did I play that one? Yeah, I did play that one earlier by mistake. I didn't realize I played it. But this is what he says about stars and what they really are.
Well, I mean, technically, if you have a light source, it's going to have a radius of light in all directions, and so it's going to give you a sphere of light, right? But it's not like a solid sphere. You see what I'm saying? Like if something's illuminating, it's going to be a sphere in that it's going to have a radius of light. You know, same goes for the stars, right? Like if the stars were like, if I was up there shining really bright as a star, from here, I would look like a sphere.
All right, so I zoomed in on the sun and showed that's not true. And we also had a picture in my presentation of Sirius A, and we can see it was circular. So clearly a human being. If they glowed as bright as the sun and we zoomed in, they would be shaped like a human being. You know, we put the solar filter on and we zoom in, we were like, oh, goddamn, that star is actually a human being, you know. So So yeah, man. If he'll believe that a human being could be mistaken as a star, then it makes sense from that level of understanding that he'll believe that a circular object can't project a circular shadow on something. So, but awesome. Thank y'all for joining. I'm going to go ahead and end now. Thank you, Kindness, for joining, man. I appreciate it. It's always great talking to you. It's always nice having somebody to chat with. I appreciate the support. And I'll be here in the chat in MC Tunes channel. So everybody go over to MC Tunes channel and we'll see what heat he's bringing on Witsit. And tomorrow on Witsit channel, on MC Tunes channel, tomorrow on MC Tunes channel, I'll be reviewing the debate with MC Tune, the debate that I had yesterday with Witsit tomorrow at this time. So at this time tomorrow, be there on MC Tunes channel and you'll see us delving into that debate. So I look forward to it. I'm a big fan of MC Tune. I did that Dark Matter talk on MC Tune's channel, so search his channel for my Dark Matter talk, and you'll be able to see me tomorrow there. We'll talk about the debate. So have a good one. I'll see y'all who'll be there tonight in a few minutes, and I'll see y'all tomorrow at the same time tomorrow on MC Tune's channel.